In the following slides, we will discuss different types of coastal erosion. The main types of coastal erosion are the following: mechanical erosion of waves, weathering, bioerosion, and mast movements. The mechanical erosion of waves is the main erosion factor in coastal environments through high energy waves or storm waves. When low energy conditions dominate, the erosive action of waves is reduced and the weather material is removed. The erosive action of water is greatly increased when transporting sand and pebbles. It has been noted that the erosion rate on the base of the cliffs was about 20% greater in areas with sandy coasts. Abrasion is greater when a fine layer of sediment is present, while when a thick layer is present, the underlying rock surface is protected. Weathering processes are mainly controlled by climatic factors such as temperature and precipitation and the rock type. Weathering is more efficient in the intertidal zone and above, as the mechanical action of waves. Coastal cliffs and intertidal coastal platforms are exposed to alternating wetting and drying from salt spray, wave swash, tides, and rain. Therefore, they are suitable environments for many physical and chemical processes of weathering. In protected areas and in erodible rocks in particular, weathering is probably the main erosive mechanism. Wave action can be solely responsible for removing the weather material. Physical weathering may occur through frost action and alternating cycles of hydration-dehydration. The rock is fragmented through the development of subsequent widening of capillaries and larger cracks. The mechanical rock fragmentation is particularly important along rocky shores in cold coastal regions, as the rocks are capable to retain high moisture levels and suffer multiple cycles of freezing, melting every year. Chemical weathering is the result of various cooperating chemical reactions, including hydrolysis, oxidation, hydration, and dissolution. The effectiveness of these processes is determined by the water quantity available and the removal of insoluble products. Chemical weathering is more important in warm and humid climates. In cold climates, the rate of chemical weathering is slow. Physical and chemical weathering often cooperate and are more effective when the rocky substrate undergoes often hydration-dehydration cycles. Erosion due to weathering is particularly active around the margins of water basins in the supratidal or intertidal zone, where alternative hydration-dehydration occurs as the water is replenished by spring or tides. Another process is bioerosion, which is the removal of rock from organisms. This process is more important in tropical regions because there is an abundance of marine biota and limestone substrates are susceptible to biochemical and biophysical processes. A crucial factor in the efficiency of bioerosion is the spatial distribution of marine organisms along the rock surface, which is mainly controlled by the available moisture and consequently the characteristics of the tide and the wave energy. An example of bioerosion processes are tidal notches. Marine organisms graze upon the rock, eroding carbonate rocks with their radula. The steep slopes of rocky shores reveal that they are unstable and prone to mass movements. On the rocky shores, many movement types may occur depending mainly on rock properties such as lithology and structure. So we may have rockfalls, landslides, or flows. Rockfalls are more often during the winter months, and this may be attributed to the frost action, the rainfall, and the increasing undercutting of the cliff base due to storm waves. Landslides are large failures that occur when the compressive strength of the rock is exceeded by the overlying load. The failure starts when the strain at some part of the rock mass exceeds its strength, so that the cohesion at that part is zeroed. All types of mass movements are driven by three main factors: the addition of material, the increase of slope inclination due to the base undercutting, and the reduction of compressive strength of the rock due to the increase of the moisture content or weathering. Landslides are often activated by changes in moisture or increased wave action. For this reason, they are most common in winter than in summer. Mass movements that are associated with movements of high moisture material are known as flows. Depending on the sediment size, they can be distinguished in debris flows, coarse-grained, and mud flows, fine-grained. Flows take place under conditions of heavy rainfall and the presence of groundwater. Here we see an example of a mass movement. The cliff has been undercut, and as a result, the material collapsed and accumulated to its base.